How's it going, everybody? Today we have an amazing problem for you guys, man. We're gonna be going over a pretty great, right? So it's called find all the lonely nodes, right? So you already know this is a great one, guys, right? So it says in a binary tree, right? A lonely node is a node that is the only child of its parent node, right? It says the root of the tree is not lonely because it does not have a parent node, right? Cool. It says given the root of a binary tree, right, return an array containing the values of all of the lonely nodes, right? So return the list in any order as these. So the ordering does not matter, so that's good. We don't need to worry about that. So they've given us a definition of what a lonely node is, right? It is a node that is the only child of its parent, right? So that's what defines a node as being lonely, right? So they've given us a clear explanation of what it is, right? I'm saying. So the root of the tree is not lonely because there's no parents to the root node, right? Because it's the root. It says given the root of a binary tree, return that, right? So let's quickly go ahead, right? So we see this, it looks pretty interesting to us for a simple binary tree, right? So our task, right? Find the lonely node, right? So lonely nodes. So we see that this is a lonely node because for choose now the lonely node because it has three, right? Sibling, right? So yeah, it's not. So one is not considered lonely because no, it's the root node, right? So four is a lonely node because there's no other nodes, guys, right? Two doesn't have another node that would, it doesn't have a sibling, so therefore it's a lonely node, only child or whatever, right? Maybe I can't see it that way a little bit, right? So we see that one is not lonely because he has four as a sibling. Five is not lonely; he has three as a sibling. But six and two are lonely node because God, right? They don't have any siblings, right? Six doesn't have I'm saying a sibling, right? So one uh, doesn't have a right child, right? And three doesn't have a left child for two to play with, right? So therefore, we consider them as lonely, right? So this one is a lot of lonely nodes, right? A lot of uh, you know, a child that don't have any siblings, okay? That have any, right? So because of that, they're all considered to be lonely, right? So hopefully you guys were able to understand now what the kind of what they mean by lonely and how to find them, right? By lonely nodes, uh, and they have no sibling, right? So what's kind of the algorithm we can approach, guys? We can do many different ways, right? We can use depth first search, breadth first search. We know we're gonna have to do some kind of traversal of the tree, right? And as we're traversing, we just keep track of all of the lonely nodes that we encounter in our traversal, right? And at the end, we just return that list, right? The array containing all of the lonely nodes, right? So yeah, because we're gonna do a simple check while we're traversing, right? If our, we could say that if our parent, right, doesn't have another child, right? So for a particular node, right, if my parent, right, say for four, right, my parent does not have a sibling, does not have another child, right? I'm the only child of my parents. Then I could say that I'm a lonely node because I don't have any sibling to play with, right? This is how I'm going to do that check, guys, right? So for uh, easy understanding, we're going to be applying the breadth first search. You can use depth first search as well. The logic is essentially the same, right? Keeping track of the parents, right? So that we can check our parents. Does our parent have another child, right? I'm not even a child, then you could say, cool. If it does not have another child, then I'll mark myself, add myself to output list and say, yo, I am a lonely node because I don't have any sibling, right? So that's kind of the whole algorithm, right? So we're going to do a level order traversal of the binary tree, right? And then we're going to mark nodes accordingly as we're doing that, right? So let's quickly go ahead with the implementation, guys, right? Hopefully you guys are able to agree with the approach that, we're about to go with. So let's quickly go ahead with that. The comment section as well, right? If you have any doubts or, if I'm not going to bother the right way, right? Let me know so you get some kind of feedback and interact with each other, right? So make sure that you do. Okay. So we have a queue, guys. Gotta be a queue of what? Of tree nodes because we're be doing level traversal. Okay, we're gonna add the root node. Okay, after we do that, we're gonna need some kind of a list, right, to hold our results. Okay. And then, yeah, we don't have a while loop, right? Textbook EFS for applying guy, right? Q, that empty. What we're gonna do, we're gonna get the size of the key, right? Is everything in that level, right? And then what we're gonna do, guys, are the size. So we're gonna do that I different size. As in size, right? I plus plus. So we're gonna do, we're gonna take the node at a time. We're gonna put all the nodes there. View that poll. Okay, let me make sure I create enough space for you guys to see what's going on, right? So we take the node out of the thing, out of the queue, right? And then what's next? We're gonna do a couple checks. Right? So a node that left is not null, right? If it's not null, then we want to visit it as well, right? So we add it to the queue so that it can be processed as well, guys, right? Okay, and then we gotta do one additional check, right? Because we just, that's it, right? When we do a level or traverse, right? But we need to do a couple check, right? So we're gonna check that node that I just added, right? Add it to the queue, right? Is it a lonely node, right? What's lonely? It's a node is lonely if its sibling, right? It's other, it's the left side, the left child, right? If it's the right child, my parent is not null, right? She need to have a sibling. Then we know that I'm not a lonely node, right? But if my sibling's null, right? Then because of that, guys, right? We're gonna say we're gonna add it to our results because we're keeping track of all the lonely nodes, right? So we're gonna say that node, right? Its value, because the values, that's what we're worried about, right? We want the values of them, right? Yeah. And then we do the same check, guys, the same check for the right side. The right side not null, right? We know it needs to add it to the queue so that it can be processed, visited as well, right? And then we check if it's the other child of my parent, right? Is it null, right? If it is null, then I can say that I am a lonely node, guys, right? It looks good so far, man. I think we did a pretty decent job. So I think we can simply return that to the caller, right? So we initialize our queue, we added the root, and then we start doing the level order traversing, right? So we look through everything at the level. We take node one at a time. We check node the left child's not null. Then we add it to the queue, right? And then we check is the right side null. If it's not there, we know that the left child is a lonely node, right? See how the parent is helping us in doing that, right? So when we use the EF test guys. So let's press run code, see if we pass a small test case. So it seems like we did all right. Let's press submit. All right, looks like we passed all the test cases, guys, right? So yeah, I want to thank you guys for taking the time to kind of watch the video, guys. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching again, and I'll see you guys in the next video.